So here we're given this quadratic function, and we're asked where this function intersects the x-axis. So this is a parabola that opens downward, as shown by the negative coefficient of the x squared term. Because if you do the expansion here, you'll get a negative 2x squared. So qualitatively, the parabola might look something like this. And these are the 2 points where the parabola intersects the x-axis. And they're asking us to find the sum of these values, or x-intercept. So essentially, we're looking for the points at which, or the x value for which the value of the function is 0, because that's where the y value is 0. So what we'll do is we'll equate this to 0 and find the values of x that would satisfy that condition. So really it's just about solving this. Now here you want to retain the square form, and you'll see, and I'm going to actually move it to this side, like to keep the coefficients of variables as positive. Then divide both sides by 2. Now at this stage what I'm saying is not to square this, because it's easy to solve this by saying x minus 3 is either equal to 5 or x minus 3 is equal to minus 5. So what you don't want to do is to do the expansion, x squared minus 6x plus 9 equal to 25. Then you get a quadratic, you factor it. All that will still give you the correct answer as well, but that's additional work. So here the 2 conditions will give us x is equal to 8, and here x is minus 2. So those are the 2 roots, meaning these points are minus 2, 0, and 8, 0. They're asking for the sum of these 2 terms, minus 2 plus 8, which is 6. Answer choice C. So that's one way to do it. The other one is, once you realize that A and B are the roots of the corresponding quadratic equation, that what they're really asking for is the sum of those 2 roots. So if you have, if you have a general quadratic equation of this form, and R1, R2 are the 2 roots, then the sum of those 2 roots is minus B over A. So that's an important property to know. And we're going to apply that here, because that's really essentially what they're asking for. But to do that, we have to first write this in a standard quadratic form. So I'm actually going to multiply both sides by minus. As I said earlier, I like to keep my coefficients of my variables positive. So if you multiply both sides by negative, it would become that. This side stays 0. Minus 1 times 0 is 0. Do the expansion here, x squared minus 6x plus 9. Distribute the 2. And I'll combine just the constants here at the end, and that's the corresponding quadratic. You can either divide by 2, you don't have to, but you can. It's the equivalent when it comes to finding the sum of the roots. And that would be this. So the sum of the roots, if A and B are those 2 values, A plus B would be, not to confuse with the A's and B's here. Maybe I should do R1 plus R2, but that really just represents A and B. So that would be minus of minus 6. Remember, you have to take the minus into account, because this formula is for when everything is positive. So minus 6 divided by A, which is 1, and that again turns out to be 6. So the answer is 6. So you can take either approach, but it's important to understand these relationships and looking at it from different angles. So to recap, the answer is C.